Today's problem, powerful integer, difficulty medium. You are given a 2D integer array intervals of length n, where each intervals at I is a 2-element array with a start and end. So it's an array of 2-element integer arrays. The elements in the array represent the start and end of a closed interval. All integers from start to end inclusive are in the interval. You're also given an integer, k. An integer is called powerful if it appears in at least k intervals. Find the maximum powerful integer. If no integer occurs at least k times, then return -1. Okay. This example, the first example, is probably the easiest to see. It's probably the easiest to see what's going on. It might be more fruitful to do a different one, but so let's take a look at this one. We have 3 intervals. K is 2. We need numbers that occur in 2 intervals. Actually, all the numbers from 1 to 6 are represented here, but 1 and 2 only occur in this interval. Now 3 occurs in this interval and this interval, so that's 2. 5 and 6 only occur in this interval. 4 occurs in the middle interval as well as the last interval, so that's 2. And the maximum is 4. All right. Constraints. And the array of intervals will be between 1 and 10 to the 5th, 100,000. Intervals. Wow. You have some big intervals here. They range between 1 and a billion. And k will be between 1 and 100,000. Expected complexities n log n. So there's some kind of sorting going on here. Topic tags. Hash. I don't see. I don't think we're really going to hash anything. Sorting, yes. Map, yes. All right. Well, let's take a look. So there's a common technique. Let me scoot this over so maybe we can see more of it. Actually, let me try to pull it across first. All right. There's a common technique when we're using intervals. And let me see if we can get down so we can see. Oh, we can't see all of the intervals. You know what? I think that's probably okay. Let's just start with it over like this. As I was going to say, there's a common technique when working with intervals, and that is, well, I was going to say prefix sums, but we don't really need the entire prefix sum. I mean, if we have a sorted, list of numbers, we can keep track of intervals by just keeping track of the start of the interval and the end of the interval. And the way we do that is, I mean, imagine we're doing a prefix sum. If we put, you know what, I think this thing is off a little bit here. No, I guess it's okay. Yeah, if we keep track in the map, and this is a tree map, so the keys are going to be in sorted order. They'll be in ascending order. If we keep track, every time we see a number as the start of an interval that we saw it, we increment the number of times we've seen it. And every time we see a number as the end of an interval, we decrement not the number at the end, but the next number, because the number at the end of the interval is still in the interval. So we decrement the number following the end of the interval. Now, if we do a prefix sum across all of the across all of the numbers, then every time we hit the start of an interval, the count is going to go up. Every time we hit the end of an interval, the count is going to go down, and every number in between is automatically taken care of. We just need to keep track of the transition points, the start and end. Okay. So that's what this is doing. Okay. We're going to go through the intervals, and every time we see a number as the start of an interval, we're going to increment the count by 1. Every time we see a number as the end of an interval, we're going to decrement the following number by 1. So let's see if we can let's see if we can set that up with example number 3. I mean, now the reason this is n log n, we're not actually doing a sort, but the tree map internally is doing a sort, so we have to count that. The tree map operations are not O of 1, they're O of log n, so we have to count that. Anyway, let's see if we can. You know what? Well, actually, now that we have that out of the way, maybe we can scroll this up. All right, yeah, let's do it right there. Let's do it right there. I have to sort of like manually sort this now. So let's take the smallest interval that we have, which starts at 5. So let me get a pen. So we'll say, all right, we saw 5 one time, and that went to 8. So that means we're going to go to, oh, you know what? Do I need to leave some space in there? No, actually for this one I don't. 9 is going to go to -1. Okay, what's the next smallest? The next smallest is 9. Well, starting at 9, but then it goes to 24. All right, so we see 9. That means we got to increment 9. And that means that, let's see, can I erase this? That means that we are going to increment 9. So 9 now is at 0. It was at -1, but now we're seeing it at the start. So now it is 0. That is going to go to 24. 24 is actually, I got to leave a little space at the bottom to fit this 29 in there. But we're really going to go down as far as right about here and say 25, which is the number after the end of the interval. We're going to set to -1. Okay, what is the next one? We've got 12, we've got 17, but we've got another number in between here. So all right, let's start with the 12. We see the 12. 12 is going to give us a 1. And the 17 is actually going to give us 18 as a -1. 1 past the end of the interval. Okay, 12 and 17. We had 9 and 24. What is the next one? The next one is going to be 16 and 21. Okay. 16 and 21. All right, so we'll go 16. That's the start of the interval. And 21. So we'll go 22, which is 1 past the end of the interval. How many numbers do we have here? 1, 2, 3, 4, 5, 6, 7. We hit 9 twice. So I think there's only one more interval. What is the last interval? The last interval is 17 to 29. So 17 is the start of an interval. Jammed those a little bit close together. But okay. And then 29 is the end of the interval. So what we'll put down here is 1 past the end of the interval, which is 30. We'll put it at -1. All right. Now we have a loop through the map. We're going to go through every entry in the map. We're going to call the key the num, and we're going to call the value the delta. Okay. So first one right here. If the delta is greater than or equal to 0, which it is, okay, so we need more variables. We need temp. Oh, we already have those up here. Let's initialize those. A and S is -1. That's in case we don't find anything. Temp is initially 0. So delta is 1, it's greater than or equal to 0. So temp, we're going to add 1, we're going to add delta to temp. So that's 1. Is temp greater than or equal to k? What is k? K is, for this, it's 3. Is temp greater than 3? It isn't. All right, let's go to the next entry. Okay, 9. Delta is 0. If delta is greater than or equal to 0, temp, well, we're going to add 0 to temp, so it stays the way it is. Is temp greater than or equal to k? No, it still isn't. All right, next number, 12. Delta is 1, so we add 1 to, we add the delta to temp. Is temp 2 greater than or equal to k? No, it isn't. Okay, next number, 16. All right, the delta is 1. Add the delta to temp. Is that greater than or equal to k? As a matter of fact, it is. So we have now seen 16 in 3 intervals. Okay. Is that right? That is right, because we have 16 in the 9 to 24 interval, we have 16 in the 12 to 17, we have 16 in the 16 to 20. So that is right. So answer now becomes 16. Okay. All right, next number. Next number is 17. The delta is 1. If delta greater than or equal to 0, yes, then increment or add delta to temp. So temp is 4. If 4 is greater than or equal to k, which it is, then answer equals number. So we now have a higher number than 16. Okay, and that's right. So 17 is in the 16 to 21, 12 to 17, 17 to 29, 9 to 24. All right, next number, 18. The delta is -1 if delta is greater than or equal to 0, which it isn't. So we're going to come down here. If temp is greater than or equal to k, which it is, then answer equals num minus 1. Well, we already have, that already equals num minus 1, actually. We'll leave it at 17, and temp plus equals delta. actually a negative delta. So it goes down to 3. All right, next number, 22. 22, if delta is greater than or equal to 0, it is not. We're down here at the else. If temp is greater than or equal to k, which it is, answer equals num minus 1. Num is 22, so num minus 1. So answer is going to be 21, right? And temp, add the delta, which is negative 1. This is now at 2. Now you can see that the rest of the deltas are negative, so nothing interesting is going to happen after this point. You also notice that the numbers 18, 19, and 20, is that right? So 18, 19, and 20 are going to be here. They're also going to be in here. They're also going to be in here. So 18, 19, 20 also appear. Oh, it says it right down here. They also appear in at least 3 intervals, but we don't care because they're in this interval right here. And they get swamped out by the fact that we only care about the largest number in this interval. There's no sense really keeping track of 18, 19, and 20 because we already know that they are not going to be the largest number in that interval. So that's it. That's going to be the answer. 21. So there's a walkthrough. There's the implementation. Let's get rid of some of this writing here and try to run this. Let me do a quick sanity check on this. All right, good. Well, let's submit it then. It's a little bit slow, maybe a lot of people doing algorithm challenges this afternoon. All right, there we go. All right, what did we learn there? Well, it's an interval problem, and as I said, a common technique with interval problems is just keeping track of start and end of intervals, also prefix sum. And that is it. Go ahead and like the video, subscribe. I'll send you problems of the day, every weekday, and we'll see you next time.